Thanks everybody for joining. Everybody on LinkedIn, everybody on the platform, welcome. Hey Zach, I see you here. Welcome. I think this might be your first office hours. Sabrina, hey, how you doing? Navadeep, Imesh, Mike, Raphael, of course. My name's Brandon. I am a technology journalist. I've been in the industry for getting on 15 years now, and I am one of the people behind DevHeads, the community, one of the many people behind it. So thanks to everybody who's contributed, is involved. Couldn't do any of this stuff without you. We're going to go around the horn and allow everybody who's on platform to introduce themselves because they might be contributing a little bit today. And Raphael, why don't we start with you?
Sure, thank you. I am a former STM32 fanboy, and since then, since about 3 years, have been trying to widen and do things with different vendors as well. Currently exploring the Raspberry Pi Pico, but also NXP and WCH microcontrollers.
Awesome. Thanks for that. Imesh?
Hello everyone, this is Umesh and I've been 10 years building embedded software and hardware from Pune, India. Thank you.
Welcome. Navadeep, you want to say hi?
Yep. Hi everyone, I'm an electronic designer from Bangalore. I work on RF communication stuff. Hello.
Cool. Hey Mike, what's going on?
Hey everybody, Mike Furian here. I've been in this kind of IoT hardware and embedded firmware and system solution space since back when we called it machine-to-machine communications. And now I do advisory and fractional executive work with IoT companies.
Great. And everybody else, if you don't have your mic or your camera on and you want to just say hi in the chat or anywhere else, go ahead and do that. So today, the topic of discussion is, there's so many ARM microcontroller vendors out there. How do you start? Where do you start? And I think for a lot of us, and this is where I want to have this conversation end up. For a lot of us, it's like, well, I'm an STM32 fanboy, like Raphael was saying, so that's just the ecosystem that I play in. But that's number one, not always going to be the solution. You might have to step outside your comfort zone a little bit. And then number two, for a lot of us, when you're starting out, you don't have that allegiance yet, so you're just trying to figure out, where you should go and why. And that can be really confusing. And part of the reason that can be so confusing is, let me share my screen, or a different screen really quickly. I went and pulled up a comparison. I don't know how well you'll be able to see this. A comparison of all the ARM Cortex-M class devices, or most of them, available now. So you'll see that there are various ISAs here, right, across the M0 through the M7. But we start going down here, and V8M, this is with Trust Zone enabled, and then there are various DSP extensions. But you start getting down into hardware divide and some of the DMIPS for megahertz and core mark scores and the number of interrupts, and a lot of this looks like a lot of the same information across this table, right? And this is from ARM, right? This is the base IP that's being used to create microcontrollers, or that a lot of the MCU vendors use, right? So when you go to NXP or TI or ST or Microchip or whomever, right, they're working from this template and then say, hey, go make something great. Well, let's take that a step further and let's go see what all of this results in from our friends at DigiKey. Okay. All right. So here's DigiKey. This is just the microcontrollers, and let's just assume that we're going to be working with 32-bit. So I'm just going to select 32. All right, and of course we only want products that are active. Now let's see if we can go and find our architecture that we're looking for. Nope, here it is. Core processor. And what do we say? Umesh, you think an M4 is a good, a popular enough one?
Yes.
Okay. All right. So we've got down to 233 results. Let's apply that and see who manufacturers are. And it's most of the friends that we'd expect here: Renaissance, ST, NXP. So we start looking at these different devices, and I'm just going to go over to the connectivity here. We got a lot of the same stuff, right? So this becomes a little bit of a difficult proposition if you're not exactly sure which way to go. So as part of this, I created a quick little, I sourced a quick little checklist guide from a couple of different places on the internet. But a lot of these devices are pretty much the same. Let's look at the speeds here. 120, 150. I want to ask the panel here before I move on into my little checklist. How do you go about selecting a microcontroller? Obviously, there's always it depends. What are your application requirements, right? But I know, Umesh, you're an STM32 fanboy, just like Raphael used to be. Is that just where you start? I mean, is this just the default?
I mean, these days, yeah, very often. But earlier, I used to. I mean, my first choice was like everybody else, like 5, 6 years back. First, everybody look for 8-bit if 8-bit can handle the efficiency and price and everything. So, of course, back then they used to call Atomil, right? So now it's a microchip. So 5 years back, I used to start everything in a lens of Atomil, whether it's a 8-bit, even the 32-bit portfolio, which Atmel has to offer. But right now, since STM32 pretty much cover all the price range from low cost C series to even C0, G0 to, high end H7, even dual core or something. So I kind of feel like STM32, except the Wi-Fi, that connectivity, but you can get it by putting other chip. So um, I mean that's why this is the reason why I stay with STM32. And then I also feel it's not very easy for somebody who's a new, let's say, if you're working on your very first project, and maybe you have to make a decision, even if it's just a very small, let's say just control opto isolator or something like that. And maybe that can be done with 8-bit as well, because you're just turning something on and off high voltage. But still, making a decision takes a lot of time. I remember my very first project. I was working for uh, very small engineer bureau or something in Germany, they call, as a student job. And that guy used to get very small projects. And I remember my first selection for just a 8-bit AVR controller. It took me like 2 days, because it's my first time. I have to read document, understand, and make sure I can deliver that. So I think people don't take that much risk when it's very first time. As if you're inexperienced, maybe then it's very different story. But still, that's reason for me go for STM32. And then of course everybody would agree they have the best documentation. So
um, all right. Well, I'll pose a similar question to you, Navadeep. I mean, you work with a whole lot of different architectures, and I mean, even just in some of the kit reviews you've been doing in the last couple of weeks, you've been through 3 or 4. How do you choose? You just whatever the boss says to use, whatever meets the cost constraints.
Yeah. Yeah. So cost definitely comes into play, but generally once you go with some manufacturer, you get that bulk price down uh, for all the series of controllers. So they won't have certain cost constraints saying we give if you order in bulk, we will have 50% discount on the F3 series and not on the F4 series or sort of it. So that's why the cost is the secondary thing, but primarily to look at the performance what we want. So if it's automotive use case, then look at having multiple CAN peripherals in them, so we can have uh, yeah. specific to the use case, and also if it is something like to do with the display driver or high performance, then go with the H series also. I'm just referring to STM series because that's what I used vastly. One thing which helps to boil down is their product selector guide. If you go into their website any product family, they will have a chart put with, maybe if I share the screen quickly.
Yep, go for it. Let me, I'll stop sharing.
Sort of, application. Is it up? It's up.
It's coming, yep. Oh, we could see it, and now I don't. Oh, there we go.
Oh, yeah, something of it. So if I go, this is the generally in M series. With the Cortex M, they have categorized into like high performance, go with this particular series, mainstream and ultra low power. So first point of contact is to look at what feature your application demands, and then look at this particular categorization which they've done, and pick one of them. Or again, if you go with one of them, there are a variety of variants in them saying that this will offer 512 KB memory, then different ranges of processors. So again, yeah, I mean, a person would have to know like what would suit their application, what is not overkill and what is not very low for the application, and just on that fine line, right? Going over, sometimes we opt going overkill with the memory or something, thinking in the future you might expand, like if you have to have certain sections of the memory frozen for storing a sequence of shorter parts of it. But generally it's like, yeah, look at them and application specific. It's not very easy for to do it for the first time. You might end up choosing the pricey one or the overkill one, but still it works.
Raphael, you said you're a former STM fanboy. So what happened?
It's not that I have like a super bad experience. Maybe the most interesting experience I've had with ST was we had a design with the G4 when it just had come out like a month after, and the Errata PDF was not uploaded yet. And we ran into basically everything that is now in the PDF. So this happens, and ST, of course, has bugs like everyone else. But the reaction time is, I think, quite slow. The other thing is, I mean, they got to be running out of letters for product lines, and it's hard to keep track what is going on there. Their tool, the CubeMX, is like a love-hate tool, because on the one hand, the capabilities are nice. On the other hand, the code that it outputs is completely atrocious. And the HAL, even if you don't use a generated code, is also, it's not atrocious, but it's not great. What else? I mean, for me, the departure from this ecosystem was more because I got curious about ESP32 and did things 52 also. Quite a nice lineup, 53 and what's coming now. And also I got into just different designs which involved needing dual core, which is why I'm now doing the Pico. I'm not sure, probably ST has some dual core, but they are only powerful dual cores, or like one strong, one weak core. The Pico, meanwhile, is just 2 weak cores, and that is a nice thing for some applications. But it's not like there's something fundamentally wrong with ST. It's just I wanted some more diversity.
Awesome. Zach, welcome, man. Do you wanna introduce yourself real quick before we start putting you through the paces?
Yeah, sure. I don't know how my network is, but like, yeah, I've been a software developer for quite a while, and I just recently started working on like embedded applications, maybe in the last year. I like using ST. I do have experience with Pi and I think PIC controllers, but like, yeah, quite into it. I'm quite an ST fanboy still, I guess.
Very good. Well, welcome, man. We'll ease you into this. We'll ease you in. So, Mike, from your side of the of the fence, um, is it just pure cost? You're just looking at, what's the most optimized for the scale that you're trying to produce?
Yeah, I think it's a lot about the ecosystem and the comfort zone. I mean, once you've invested in and got familiar with and learned the tools and the product line, for the engineering side of things, that's pretty huge. So you tend to stay right into that community until you run into something like, hey, this just doesn't have enough ports. It doesn't have this feature I've been forced out. The other thing is we don't have as much free will as we think we do in engineering sometimes, right? If this is really a production product, you have to work with approved vendors, parts that are already in stock. So a lot of times you'll choose a processor not because it's the optimum one for your design. Maybe this one's got 4 times more memory than you do, but it's already used in 14 other product lines that your manufacturer is building and buying it in large volume. And to add a new vendor is an expensive process. To add a new part from an approved vendor is in the manufacturing world where you're trying to manage inventory and things. You stick with the product lines that you have available, and that tends to be depending on the company, it can be pretty onerous for an engineer to say, look, we want to bring this new processor into inventory, into supply chain, and we want to do that because it has a little less memory and better fits, and we're going to save 50 cents, and the operations department's probably going to say no.
Sorry, I was muted. This is one of the things that I'm going to get to, and I'm glad you brought up, which is the familiarity with tools. The environment that everybody on the team is already working in is worth more than going and learning a whole new tool chain and a whole new architecture in a lot of cases. And so, yeah, it's not always developer preference that leads, that drives everything. So, I did, like I said, come up with this brief checklist. It's a source from a couple other places, including this guy, Infant Reagan. But of course, you got to define your project requirements. So if this is you and you're just starting out, a couple of things to consider. Obviously, you got to figure out what the performance is that your application is going to require, and then after that, what are you integrating into your build, right? Or are you pulling in specific type of sensors or actuators, like Navdeep was saying earlier? If you're working in the automotive sector, it's likely you're going to need CAN, just because of the nature of those networks and what the devices are and peripherals inside of those systems. So that's going to dictate a lot about what the IOs that you require are, and how many of those is obviously going to help you narrow down even further. Of course, whatever the application is, you're going to have to evaluate what the memory requirements are, both in terms of flash and RAM. Do you need, certain amount of buffers, etc. Power efficiency, are you going to be running off a battery? Are you going to be connected to AC mains? What does that mean for the efficiency that you need in your device? And then, obviously some of that starts to dovetail into the operating voltage. And then, of course, special features. Is there some specific acceleration block or something that you need? Do you need PWMs or timers? And then, like Mike was pointing out, budget. For the people on the call, am I missing anything? Is this a decent way to start? Are there any big gaping holes that I need to make sure that I put in here if somebody was going to be like, I'm going to rip this PDF down or this PowerPoint down and use this as a guide?
There's one thing, I guess, that's jumping out to me is the quality of the software ecosystem.
Yeah. Yep. That is actually on the next slide. So I said, but wait, there's more. All right. So what's the software architecture you need, and what are the libraries? And this is sort of getting into, what I was sort of foreshadowing with respect to what Mike was saying and at the beginning. I think this is a lot stickier than most of us want to admit, right? What's the available libraries? What's the available code? What can we rip down from somewhere and get started really quickly? And then, like Mike said, the ecosystem too, right? I mean, it could be the greatest, platform in the world, but if it's just that platform and you can't get into even Eclipse, right? Or like our friends over at Embeetle, like, if you don't have the tools there to support it, um, you're not going to get very far, or you're going to have to do a whole lot of extra work that's not required. And then, of course, it's also nice to have a community around it. Do you agree with this stuff, Raphael, Umesh, Navdeep?
Yes.
Yep. Oh, thanks, Navdeep. That's nice. He said it's perfect. So outside of this, anything else that we're potentially overlooking? Nope. Great. Okay. Well, if you were to start out and give somebody a recommendation, Amesh, we'll start with you, about where to pick, where to start with your on your microcontroller journey, and how to select one, maybe a vendor at first, and then use this tool, this checklist to drill down to the specific device. What would you advise?
Um, I still recommend somebody like consider the case with a new junior developer join and working in very first project, because and you are considered like a small company something, because it depends on the applications company scope. Maybe somebody would join next day Mitsubishi and he been forced to work on 32-bit dual core on very first day. So the scenarios are very different. Maybe in those companies nobody would even ask him, oh, what microcontroller you're going to choose, because it's been already there and he has to start. So I still be very conservative and look at the lens of small company or consultant perspective. And I would then, let's say, if independent consultant, like couple of consultant hire somebody like a fresh, I would again advise AVR, because it's very good to start with, and has very good user community. I'm very orthodox in that sense when I choose, for because not every project or product you're going to build will not go into space satellite or somewhere, right? Maybe sometimes you're just turning on and off some iOS, or maybe monitoring some devices, or reading some I2C data from some sensors or something, and there's no problem with to start with AVR or something. And because it has, again, I'm coming back to the reason, having good user community and good documentation online, that is what been taught by AVR to the world, that you have to create a community like AVR Frakes, and then have very active community, lot of code, lot of books, a lot of things, and then Arduino whole thing. So I think AVR is a good place to start with, and then from there, person will map their way through STM32 or much mature controller, so they can also handle the complexity that comes along with 32-bit. It's not like you pick up something and then you don't have quite experience, because everybody has a steep learning curve. We have to understand it's a complex. Like Rafael took a very interesting point about the glitch in a documentation, the code generated by CubeMX. I do have very, very bad experience. Sometimes I have to read SPI two registers to figure out SPI one's register names. And I just have to imagine, based on my experience, just think about this. Like if you're a very new developer, you will go into spy one, and then you're reading and you're saying, okay, why the hell there's no registers here, right? Or why these names are completely different? And uh, then you just freaked out. And many of people, I would say, like many express their love about STM32. Maybe it's because they have little bit of pain from NXP or other controller, because they have the worst documentation. They have very little example codes, at least back in the days. Right now, unfortunately, in a life, I don't have a time to touch their controller. Too busy in life. But when I worked with LPC 2148, 1768 or something, it was too painful. So start with AVR, then, I mean, just the orthodox. for smaller applications, and then map your way through STM32 or something. And as we discussed, like STM32 has a great offering. And then also, once you work on that, then you're pretty much ready to diversify, go to Nordic way or something, because the core remains same. Let's say you're working on Cortex M core, you do have this awesome debug capabilities, right, which comes along M4, which doesn't have the lower end of Cortex. So I think that's just my opinion. That's way I suggest.
Yeah, so actually you just brought up something that's really important, and Navadeep is putting over here in the chat some excellent points, which are that, even within the ARM ecosystem, right? Certain vendors have carved out their little niche, right? They're, like NXP. If you want automotive stuff, that's probably a good place to start. Like Navadeep is putting over here, low cost and light on peripherals is a good place for TI. If you're looking for low power wireless stuff, Scilabs and Nordic. So you just mentioned, well, you've got a baseline mesh, because they're all M4s, right, or something like that, right? How much does that software ecosystem and those libraries and then the additional peripherals that are put around potentially by the specific manufacturer impact your ability to move, laterally into some other supplier? And this is a question for everybody actually who's got experience working with multiple ARM devices.
I think it matters a lot. Let's say if somebody, because the person obviously will work with Cortex M4 Plus or something, just high-end core, not M0 or something. Once they realize how great the debug capabilities that, let's say, M4 incorporates from the software point of view, because you have again then third-party vendors, like you have a Sega's tool, Louderback's tool, and other tools that also connects and then makes you very allow you to write very sophisticated softwares. Okay, so I think in my opinion this really matters. But when we are not doing very sophisticated software, like, I mean, every software is sophisticated, don't get me wrong. Every product has to be secure. People talk a lot about security, but then my point is, like, it would, the software ecosystem for the experienced developer makes their life so, I mean, so easy and way more productive to solve much more complex software tasks, embedded software. So it matters a lot. And peripherals, I think they also matters on the cost front. But then again, these software tools and libraries sometimes reduces how much peripherals or features you want sometimes. So it's just like, it solves many things at the one shot, I would say.
Rafael, in your experience moving, from one vendor to another, but still circling the ARM ecosystem, right? How difficult is it? How easy?
For me, it was not that hard because I have previously made an effort to decouple protocol code and firmware logic from the hardware, and also using some abstraction layers which do not care about the nature of the chip. So I would say this part was easy, but then once you hit maybe I have this special case where we are sampling the ADC for super fast for a short amount of time and dumping that into the RAM by DMA. And that is not something that a common abstraction layer really accounts for. So the easy parts, the logic, the protocols, the serialization, deserialization, these things should be taken care of by software abstraction as cheap as possible or even free. But the hard parts, then this is where you should spend your time, and this is where it will become hard. At least in my experience, it has become hard. Then you have to somehow map the same thing. Okay, we have an ADC, we have a DMA, we have a pin. We need to do the same thing in very different. And all of the code is the same except this one part. This also gets challenging, gets into dependency management. It's also tough.
Zach, for you, what's been your experience? You said you're relatively new to embedded. Do you have experience moving between vendors right now in the ARM ecosystem?
I have a thing where I'm probably going to have to use, I think, Nordic for the first time. But it looks so similar that it looks like if I have a reference manual, I should be able to do the same thing. I'm lucky in some sort of way. Whoever taught me made sure I avoided using the HAL, and I ended up in Kimsys really quickly, which made it that I kind of I didn't even know this, but I found out I understood more than I thought I did because I could just move between the like ARM stuff, but just lucky in some sort of weird way. Yeah. Okay. You make enough mistakes, you get some luck along the way.
Right. The I was gonna go next to the HAL. The HAL on some of these APIs. I don't know. Sort of to Zach's point, is this a gift or a curse? It makes everything really easy until you need to do something pretty specific, and then you're dependent. How much do you leverage the API that's available through Umesh? Through is it the Simpsys API?
Yeah, yeah.
How
I mean,
much do you leverage that?
see, like if anybody start in 2011, nobody asked this question like API or something. So they all start with bare metal. So the bare metal, then come the standard peripheral library, and then the CMSIS wrapper, and now the HAL API. So I think uh, this HAL API does make your life easy for initialization part, but I still use CMSIS layer, or even sometimes go bare metal when I work on very specific sensor or specific part, because you can't deal with HAL everything. I mean, the role of HAL is uh, very limited. I think people expect a lot from it. I mean, I feel people expect to be, it's like an AI. People say, okay, you put the prompt there, and then AI has to write entire firmware for you, okay, for some XYZ I2C chip. So I think that's what happening with the HAL. But so I would not say it's too bad that it's a useless, but it would just help you to initialize peripherals. And then, like what Rafael says, like if you're working with multiple peripherals and protocols you are managing in it, then it's become very complex. And then you have to go deep down, and you have to see whether you will do at CMC's layer. I mean, of course, those Cortex layer would help you, but then you go under, down, below in a bare metal. I mean, I still use everything in a code. So it's not very straightforward. Like you write API, using API, you write firmware or something. So I think it's must to know everything, and then also to get comfortable with API, all APIs.
Well, Navdeep just pointed out that he's seen people who are working on vendor agnostic libraries and drivers for the ARM Cortex series. A while I've talked about the end of embedded. And it's like, well, if you just got these agnostic libraries and drivers, you can just rip out, and you've got this API you can rip out, then why do we need embedded developers at all at a certain point, right? Does anybody on the line have experience working with any such thing? I don't know. Navdeep, have you? Actually, he may not. No, he's his AV is disconnected. How about the rest of you guys? Anybody have any experience working with such thing? Zach, Raphael?
Yeah, I have. I've had a good experience with this, but not meaning to drag Rust into this again, like last time. But of course, it plays a role if you have a module system and generics and static dispatch abstractions that do not cost you anything. But fundamentally, if you have a driver for a display, it does not need to know how the I2C is done. It only needs to know I have like a block transfer or a single byte get or a register access. And if your driver on your target exposes such an interface, then of course the two can hook up, and your display driver can work with basically any target device where this is implemented. And if you do this, like if you check on crates.io, and like go the according section for embedded drivers, then you will find there's like hundreds of drivers which all rely on a set of one common one crate with common traits in it, common interfaces in it, which means that you have M targets for which this is implemented and N devices. And if you want to do really the cross product, then it's M times N, and that's not feasible. But with this approach, it's M plus N, and that seems much more doable. But you said you don't need embedded developers. You still do, of course. You still need to think about which SPI peripheral am I going to use for this, which pin remap, which do I use DMA or not? How do I share the I2C bus with two different slave devices, and so on? It's still embedded. It's just a more declarative way of doing it.
Yeah, but I think also, the whole idea behind DevHeads is, creating an IoT device is really difficult. And there's a whole lot of different things that you need to, different disciplines that you need to be familiar with in order to do so. This is sort of a continuation of that trend, right? Where it's like, okay, let's just narrow down the amount of responsibility necessary and time necessarily that an embedded developer is going to need, or a developer is going to need to create something. And, like you said, get into a declarative mode where you're saying, this is how it's going to be. I need to understand these things and define these parameters, but then I can move on to, other parts of the value add, more application specific stuff. In your guys' experience, is that how you feel your jobs are evolving, right? Do you feel it's, less infrastructure, more application layer, or do you guys still have bread and butter and doing a lot of the plumbing underneath? Do you want to go, Mesh?
I think I still do a lot of low level stuff. I don't see that. I mean, it can help you just to initialize what I said earlier, but I don't buy this. You should know so many things in embedded. There are so many. I mean, from whether you need DMA, even in which configuration you want, right? So, I mean, does this make a sense? How would it share the memory? Let's say if you're using RTOS in your firmware. So I think people say very vaguely with you can write. That's why I said 8-bit, unless you know what is happening behind the scene, it would be way more difficult for you to, even if you have a ready block of code, then you want to put in place and then you have to optimize again, because without optimizing, I don't think anything works. So I think I still do a lot of low level code. Yeah. Along with some APIs.
How about you, Raphael?
I guess I'm not exactly, I would like to disagree, but I cannot, because Umesh frankly has a point. Yeah, it really depends though. Speaking of DMA, if you want to do, let's say you have a task and this task has a channel and it gets some text messages, maybe this is your logger in your device and it gets text messages from other modules and then puts them on the UART and blasts them onto the host device. This sounds like something you'd have to set up the DMA ring buffer and then tell the UART to read from that and so on. But this is like 5 lines overall with everything around it. And the setup is, it's not like you're spending a lot. This can be done in a very declarative way. Now, if you want to have like a 1 millisecond sampling of your ADC, and then there needs to be this and that and the other thing, of course, then you need to deep dive.
Yes, if it's not a lot if you know what you're doing, right? If you know what you need to do. So, caveat. How about you? Go ahead, Ramesh. What are you gonna say?
And many times in the world of embedded, you try building and then you figure out how deep you have to go. Because when, let's say you put the prompt, you don't know, you're an idiot. You just know, okay, I'm gonna put this like 4 things, I need this. And then you realize, okay, I want to sample more because I'm not gonna get this. Probably you want to with certain frequency, you have to resonate the tip, and that will scan the surface, and you have to collect the data. So you then understand and then figure out, and then you go at deeper and deeper, and then you have to go low level. I think that's how I feel like every time. Like my initial thought is not what I wanted. I realize I end up with something completely different. So that is also lead me to come to this conclusion. Yeah, thank you.
That's life. Hey, Zach, how about you? Where do you see, like, how you called yourself a software developer? Where do you see you spending a lot of your time today? Is it, on a lot of the infrastructure and a lot of the low level stuff, or is it, more at the application layer?
Wait, so just a point. I just need some clarity. When you say infrastructure, what do you mean?
I mean everything underneath, right? All of the firmware that's allowing you to connect, to connect to the silicon, right? To take advantage of the ARM 32-bit ARM M4, right?
Yeah, yeah. I think it's it's all over the place. Like it depends. Some projects are simple enough that you could do them with the HAL and just you'd be satisfied. Like you need to flip a switch every this is a frequency thing. You can do it really quickly, and then sometimes your thing won't work until you get stuck. Like you think you know the solution, and then you get stuck, and then you realize I it's like Umesh said, I have to take this apart and then start again. And then you end up with the thing you wanted, or maybe sometimes not. I think it's everything. You use a HAL, you build a HAL, you build drivers, you use them again. It's everything all over the place to finish. You just try and finish.
Great. I got one more question for everybody, and I actually want to bring Mike back in for this one, which is, we've mentioned documentation, we've mentioned issues with getting response. How much push or pull does anyone have with some of these vendors, right? I think we've all worked at different scales of organizations, different sizes. And I've heard that a lot of times it's like, deal with it, right? I mean, Raphael, the story you were telling with ST sounded like you guys were inadvertent beta testers, right? That sucks. Do you have have you, in your experience, is there any sway, or is it just sort of at the mercy of the evil empire, and you'll get what you get when you get it?
And by evil empire, you mean ST, I assume.
No. I don't mean ST. I just mean whoever the mega microcontroller vendor is, right? Whoever the massive, Fortune 500 is.
I mean, the specific reference I was making to this G4 issues, we had some people from support, and initially they were very cold and very unhelpful. Though I felt like we should have had some pull, because we were observing real issues and also having the numbers to make it work for them. But then we met some of these people. I'm not sure if it was the sensor and thing or the Embedded World one trade fair. We met 2 people from them, and since then it had warmed up a lot, and they actually helped us. So maybe sometimes the human connection, or sometimes there needs to be one moment where they realize, this is a human who has a problem. And yes, they have a business problem, but it's also a person behind it struggling with the hardware that we are selling them. And then the support becomes friendlier. But this is also still just support. It's not like we have a pull on any of the product decisions. But nonetheless, this can be very valuable.
Yep. How about you, Mike? What's your experience?
Yeah, well, I agree with Raphael's comment on the human touch, because a lot of times that support is coming at a regional, local level. So you can almost, to a degree, isolate that from the business relationship. But also, I'd say, depending on the scale of your organization, any company developing a product, chip or otherwise, they know who their top 10 customers are, top 20 customers are, and they do have an insider relationship. They are inside that curve under NDA. They know what's coming 3 years from now. They have sway to that. They're getting early looks at things and stuff like that. But then also you don't have to be in that top 10 circle. I mean, but it is, not to sound cynical about it, but it has a lot to do with how many zeros there are in the account. How important are you to them, or not maybe even to the headquarter company, but to the regional organization. If you represent 5% of sales to to your region sales office, nobody wants to lose 5% of sales and feel like, hey, we're gonna lose out here, and they're gonna jump ship to another manufacturer. So it has a lot to do with volume, but not to be too cynical, because I think I totally buy into what Raphael said, to say if you don't have that leverage of volume to say you can hold that over your head to say, look, we do a lot of business with you. You definitely want to work on developing a personal relationship so you get that kind of human-to-human support with your vendors.
Zach, Umesh, anything to add here?
Yes, I agree with the human factor. If you know somebody, then they can trust you more, and then you get better off. Otherwise, I see a lot of difference, lot of different angles, because when I was in Germany, it's very easy to reach to people. Like, you gotta go to Nuremberg, you meet somewhere in embedded world or something. The amount of call you get in Germany or emails you get are very less. Let's say you're in India, my experience is very different. The moment you change the country here, nobody respond to anybody. So it's a very different field. So, but I think it's much better you have some connections, some relations, and that's where again the community also matters. Like, sometimes somebody who publish certain libraries, we can talk to that person, right? So whatever way you connect to any vendor, whether it's a software or hardware, that helps. I agree with that.
Awesome. Yep, I think also one of the big takeaways here is that people are nicer than PCs. Let's see. Okay. Thank you guys so much. I really appreciate all your feedback and your perspectives. Do any of you have anything that you want to bring up? Anything that you want to touch on or ask each other or myself or anybody out here in LinkedIn land? Anything on your mind?
Maybe one question about the subject.
Sure.
Is anybody here really in the position where you are supposed to choose the cheapest possible chip that can just barely fit the requirements that you need? Or do we all have some leeway?
Umesh, Navdeep, I'll check you on chat.
I haven't got the second part of the question. One is the cheapest one to choose, and then another one. Could you please?
So my point is, are there people here who are really under the pressure to choose the cheapest possible micro, or do we have some wiggling room, some leg room?
In my choices, I do have a room, because I work with bigger companies like, let's say, Dana, John Deere or something. So they don't care about this, smaller stuff. So you have the security in place. You have to, and then once they add some MCUs into the supplier list, they make a decision by giving a lot of time in it, with lot of consultation. So I think that's why many time only cheaper doesn't matter. But then again, I create courses and other things, so I have to look for this, create a content. So look that part, cheaper aspect, because that market is very different market. People look for whatever cheap available. Yeah.
And do you observe the advantage of having maybe a 20, 30, 40% more capable chip than you need? Because you don't have to constantly monitor your binary size. It's fast enough. You have enough peripherals. There's enough pins. All the pins can do everything, or you have more than one peripheral that can do the thing that you need. That's a luxury, but in my experience, that's why I'm asking the question. This has some very positive effects if you can afford it.
Yes. I seen a lot of companies I worked with, especially consulted with, let's say some of the Schneider Electric or something, where they are using, like Wind River or something like. So the software. I cannot talk more on that. Of course, we are online, but not everything has to be talked. So, but always the decision is made. Maybe Mike could speak if Mike wants. Always looked for having a room of 40 to 50%, because they know today you probably your application as such that you can barely make it work your task, but if your resources are more on a microcontroller, tomorrow 2 years down the line you will be requiring dual core, right? So even I have seen a solution built where, let's say right now you don't need it, but they know 2 years down the line we have this in a pipeline. So I think that way also decisions are made. So of course these decisions are not made by having, let's say, 10 cent or 20 cent leverage on the price of the MCUs. And then again, we have to understand MCU is just a little one piece on your circuit board, right? And then comes very expensive sensor systems and then power supplies and stuff like that. So I think what you are saying absolutely makes sense for high-end industrial applications. Yeah. Thank you.
We're gonna. I think you're passing the buck to Mike a little bit, which I had a similar question, which was, if you can afford it, we've talked about this a little bit in the past. If you're developing a device that can be updated remotely, it may be almost a requirement. It's like if you don't do it, if you don't have the additional headroom, you're doing something, you're making a mistake, right?
Yeah. I would add, often there's always cost pressure, but Mesh's point, it's, the microcontroller is usually not the expensive thing on the BOM these days anymore. But time to market pressure is probably the number one thing for most of us in most projects. And I'm just thinking through a number of different projects. We've chosen a microcontroller that says, we'd like to use this guy. We can save 50 cents. But then operations pushed us to say, look, we're already using that microcontroller, but the version that also supports Bluetooth, or the version with twice as much memory, let's spend the extra money and use the one that's already sitting on the shelf, things like that. So sometimes, I guess back to Raphael's question, I think there's almost always some leeway, but it always comes from additional pressures besides just getting the best fit part to the exact product, but also what best fits the manufacturing environment, the supply chain requirements of the project, and the time to market requirements.
If I may jump in, this works both ways. I've had this personally happen, that the purchasing department comes and says, you've selected this chip. Can you also do it with half the memory? Because we already have that chip. And then you're like, you don't have the firmware yet. Maybe it's possible, but...
Yep.
I have seen one situation where there is a selection from the developer and even from the management, but then they say, okay, to approve this part, to bring into the list, it's a process and documentation that would go probably, who knows, maybe 6 months to 1 year. And then even if you have your godlike features been found with godlike API or software, whatever you say, you can't choose it for the production. So I agree with Mike. What Mike says, the real scenarios are very different than what we say. Sometimes maybe the decision that we make is not what we love. We just make because that suits the best to that circumstances or company or supply chain or operations or whatever.
I think it's really interesting what Mike pointed out about, time to market is probably the bigger pressure these days, right? So it's, if we have to spend a little bit more, but we can get out faster, and maybe we iterate later, right? Especially if you can update, hey, we got a little headroom, we can fix the bugs later, we can do some stuff later. Let's just get this thing into the market. That's super interesting. Something you don't usually think about. Yep.
And that's where we need more memories, and we have to have a thought process of having, let's say, dual core. Do we need that? And that's how even the silicon vendors are making their microcontroller having M4 core along with, let's say, high-end processor together, right? So very, very complex design architectures are coming up right now. Yeah.
That's great. All right, guys. Well, thank you so much for your time. I'm going to have to fly through these next few slides. Next office hours meeting. I actually did not have a chance to update this. I want to talk to Petter and see if we can go through how to find information online. That's something he brought up a while ago as a developer. But this is right now TBD because he's been traveling in China. Next engineering hour is going to be engineering hour. Is not going to be this Sunday, but Sunday after. Amesh, you want to talk about what you got coming up in the next few ones of these? You're muted.
I'm sorry. So we'll take this opportunity in engineering hour to speak about Cortex-M architecture. It's very interesting what has to offer the Cortex-M layer. So I'm looking forward if somebody wants to, I mean, this session is especially for the people who want to move from the 8-bit or from the maker to the professional microcontroller development. Thank you.
Great. We got several kit reviews in production right now or in the works right now. So keep an eye out for that in the server. And then next week, we're going to be publishing Understanding Embedded Memory with Christoph. Sorry, I just didn't have enough time to get that one produced this week, but we've got a couple of those in the can. And then you can see some of the additional demos we got lined up after that. And let's see. What can we do to get better by 1% next week? If you have any suggestions, either scream them out or drop them into the server chats or the suggestion box, which is a channel there. And does anybody have anything they need or want to offer to the community? Feel free to drop it into the server as well. Here's a list of resources that you can leverage. These will be in the notes of this session, which will be dropped into the server under the office hours notes section, and then also into a post that's dedicated to this today's meeting. Then thanks for bringing your grain of sand. Appreciate all you guys for coming, and we will see you next week.